Okay, this is our third day of trig, and I am trying to keep you caught up with how this stuff works. Worksheet 4.2, number 1. No calculator allowed on this one because we are going to be doing all this stuff in our heads. Find the values of all 6 trigonometric functions of the angle theta. All right, can you name one of them? I kind of like to start with sine. And there are 6 functions. It's kind of important for you to know what the 6 functions are. So it's sine, cosine, and tangent of the angle. Okay? And I'm going to say sine of the angle, cosine of the angle, and let's not do degrees, let's just do theta, because it might not be degrees, it might be in radians. All right, so sine of the angle, cosine of the angle, and tangent of the angle. This brings up an important point that I want to make sure you get here, is that when you're setting up any trig problem, you've done this for many years, you always have the function. The next thing you have is an angle, which again, you're used to having degrees, you know, like sine of 30 degrees, but now we're using these radians, which are kind of like, they're a different way to measure angles. And then the next part is always a fraction, and it's always like the sides. All right, so let's just talk in general about a nice simple one here. Let's say that I had, this is a 3, 4, 5 triangle. You've heard about that, right? Triangle before. So sine of the angle, if I pick this to be my angle I'm talking about, sine of that angle would be, sine is opposite over hypotenuse, right? Okay, so here's the opposite one over the hypotenuse. It's right here. So this would be 4/5. That's just a typical problem. Now, what is that number of degrees? We'll show you how to figure that out later. But right now, the point is that this is either degrees or radians, and these are 2 side lengths. Right, so that's whenever you see one, if you see like cosine of theta is equal to 5/7, you should know, oh, that's where the angle goes, that's where the side ratio goes. And if you don't remember what these ratios are, like cosine, I automatically know that it's adjacent over hypotenuse. But you know what I'm doing kind of in the back of my head to remember those? It's SOHCAHTOA. And sine is the opposite over the hypotenuse. So sine equals opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Okay, so there's my sine, cosine, and tangent. And all of their ratios that kind of go with them. So again, when you see a problem like this, I hope you just right away go, oh, I know that's where the angle goes, and this is ratios. And if it's cosine, it's got to be ka, like from SOHCAHTOA, and the cosine is adjacent over hypotenuse. So this must be an adjacent side, and this must be the hypotenuse side in the triangle. All right, so now back to, what are we using this for? Sine, cosine, and tangent. I need the other functions. Okay, if sine of this angle, the sine of this angle right here will be opposite over hypotenuse. Okay, you gotta have that memorized. SOHCAHTOA. You write it on top of your paper. SOHCAHTOA. Sine is opposite over hypotenuse. Opposite here would be the 4. Hypotenuse would be the 5. It would be 4/5. Okay, cosine of the angle would be cosine ka. Cosine is adjacent over hypotenuse, and the adjacent side here is this one. Over the hypotenuse is this one, so that's 3/5. And tangent. Tangent is opposite over adjacent, so what's the opposite one in this scenario? The opposite one's over there, so that would be 4/5. Now that's 3 of my functions. What the heck are the other 3 functions to make a total of 6 trigonometric functions? I need to know what these guys are. So hopefully you've already been taught this, and this is just a review, but in case you haven't, here's what they are. S always goes with a C, so sine goes with cosecant. And I think people always think sine and cosine are the ones that go together. You sound kind of like Batman and Robin. They go together, but they don't. In this case, sine and cosecant go together. And cosecant is the exact flip of what sine is. So cosecant is 5/4. You just take these 2 and flip them around, okay? Next up is cosine. What does that go with? Cosine, you remember how C and S kind of go together? If it's a C, it must be an S. And you know the other function is called secant. Okay, so cosine goes with secant. Oh, and I forgot the angle. Use the angle. Cosecant of the angle. Secant of the angle. These don't make any sense unless there's an angle in there. So I always put theta for like a placeholder angle. So secant is the flip of this one. So it's the flip 5/3. And the last one is, what does tangent go with? This one actually kind of makes sense. There's no S and C thing going on, but tangent goes with cotangent. And those are the only two where they're co-functions. And they're also related in this way where they're inverses of each other. You just flip them over. So the 4/5 becomes 5/4. So that's how you do that kind of a problem. You start off with your 6 functions or these 6 functions. And you start by doing, sine, cosine, and tangent, because you know those are opposite over hypotenuse, and adjacent over hypotenuse, and opposite over adjacent. And then to get these other ones, you just simply flip that over. All right, so let's try another one here. On this problem, I got to go read the directions to see exactly what they want on this one. Okay, I'm back from the pause and realize it's just letting it do the 6 trigonometric functions again. So I just write them out: sine, theta, cosine, theta, tangent of theta. And the ones that go with them: CSC is and of theta, secant of theta, and then tangent goes with cotangent. Okay, right, they're each equal. All right, so the first one I'll start with is just find an easy one. So I've got my sides. I've got, what have they given me? They've given me, let's see, from this angle's perspective, they've given me the adjacent and the hypotenuse. So which one has adjacent and hypotenuse? Oh, yes, that's cosine. Cosine is adjacent over hypotenuse. All right, so I'm going to put that one, I'm going to do cosine. It's adjacent over hypotenuse. So it's adjacent is 8 and hypotenuse is 11. All right, so that right away tells me the secant one, and that's 11. Great. All right, now how on earth, though, am I going to get sine? Because sine needs opposite over hypotenuse, and I don't have the opposite side. I don't know what this is. I need the opposite side. Well, I can do it. A squared and b squared and c squared. Remember that whole thing? A squared plus b squared is equal to c squared. All right, so I'm going to say that my 8 squared plus I don't know what squared is equal to 11 squared. 8 squared plus b squared is equal to 11 squared. That's 64 plus b squared is equal to 11 is 121. And then I subtract 64 from both sides. And I get b squared is equal to whatever 121 minus 64 is. 57. 57. And so then b squared is 57, so b would be equal to the square root of 57. Now, as I recall in this worksheet, we weren't supposed to use our calculator to get these answers. So I guess we're just going to have to leave that side as the square root of 57. I hope I did that right. Doesn't feel like that's for sure right. You could maybe double check my math to make sure I didn't mess that up, but I think it's the square root of 57. All right, so if that side right there, so it's the square root of 57. So now I've got to go back through this problem and do the rest of it. Sine is opposite over hypotenuse. And I now have the opposite side from this, and it is the square root of 57 over the hypotenuse, which is 11. So then the cosine can't just flip it over. That's easy. 11, 7. Okay. Tangent. The tangent of this angle. Tangent is opposite over adjacent, and so opposite side over adjacent side. 57 over 8, and then just flip it over to the last one. Okay, that's how you do that kind. Let's move on to this other kind. Assume that theta is an acute angle in a right triangle, satisfying the given conditions. Right, so it's telling me it's an acute angle, so I can draw this, and I can say this is theta. It's some acute angle. Acute just means that it's less than 90. And it's in a right triangle, so that here I've got my right angle. So those are going to make the triangles kind of look like this. And then, again, I draw pictures for these things. You aren't going to draw too many pictures in this unit. You're going to draw lots of them. You never draw too many pictures when you're in trig. All right, so sine of theta is 3/7. So this is theta, and so where are the 3 and the 7? Sine is opposite over hypotenuse, right? So really they've told you that the opposite side is 3. So from this angle's perspective, where's the opposite side? Here. That's 3. And the hypotenuse is 7, so that's 7. So if you think about it, I'm going to need to figure out this sine to be able to get other functions like cosine and tangent and stuff. So I'm going to use the 3 and the 7 to figure out what this side is. All right, so setting up a squared plus b squared is equal to c squared. And a is going to be like this, b is going to be like this. So I'm going to say a, I don't know, so I'm going to put a plus b is 3 is equal to c, which is 7. All right. So then a squared plus 9 is equal to 49. Subtract 9 from both sides. A is equal to 40. A squared is 40. And so final answer then for A would be the square root of 40. Technically, plus and minus the square root of 40. But since this is a real triangle that can't be negative, this side right here is the square root of 40. All right, so now that I've got all 3 sides, I'm supposed to get the remaining trigonometric functions. Well, we've already got sine, so what we're saying is figure out the other 5. There's a total of 6 functions. So sine, cosine of theta will be coming next. Cosine of theta, cosine is adjacent to the hypotenuse, and that would be this one. So that's root 40 over 7. And then cosine, and the next I got to do is tangent of the angle. Tangent is opposite over adjacent, so this is opposite. This is adjacent, so it's 3 over 40. And then to get the inverse functions, all you got to do is flip them. So sine and cos can't go together. Remember, it goes with c. All right, so cosecant of theta would be just flip the 3/7 to 7/3. And then cosine goes with secant. Secant of theta, you just take this answer and flip it over. All right, I think you get the idea. So they're by giving you 2 of the sides here. Remember, this is where the angle goes, this is where the sides go. By giving you 2 of the sides, you know you can make the 3rd side using your Pythagorean theorem. Once you got all 3 sides, it's easy to get the answers for all 6 functions. All right. Next one, solve for the variable shown. This kind of problem like number 15. If you're trying to get this x11 right here, you are going to need trig. You're going to have to set up one of these classic sine of 30 degrees is equal to 1/2, that kind of thing, where you have a degree here and you have sides here. All right, so what should I use? Well, I have this angle is my key angle, right? So from its perspective, I have the opposite side and the hypotenuse. Which one does opposite and hypotenuse? So, COA, I can clearly see the opposite and hypotenuse with sine. So I'm going to use sine of some angle. Do I know the angle? Yes, I do. 34 degrees is equal to, and it always ends up being a ratio of 2 sides. You know, a number up here and a number down there. So what is sine? Opposite over hypotenuse. What's the opposite side? What's the hypotenuse side? That's the point. I don't know what it is. So I'm doing x right. Now all I've got to do is solve this for x. I got to get x alone. Wouldn't it be really nice if I knew what this number was, what sine of 34 degrees is? So you just grab your calculator, you type in sine of 34 degrees. This is one where you'd have to use a calculator to get the exact answer, because nobody I know knows what the sine of 34 degrees is. So you grab your calculator, you type in sine of 34, and I'm going to just do it off to the side here, and I'm going to make sure my calculator is in the right mode, radians versus degrees. You may want to check that. I'm going to pause for a second and show you where that is on your calculator. Okay, so I've got my calculator app, TI SmartView, up on my computer here, and I am just trying to show you how to check if your calculator is in the right mode. Hit the mode button, and do you see how there is radian and degree mode? I'm going to have you change it right now to degree mode. That's what most kids are used to, is degrees. So I'm going to have my calculator in degree mode when I do this next problem. And so now I'm going to get out of that, and I just make sure it's selected on degrees, and it is. So I'm going to quit back out. So now I'm in degree mode. So when I type in sine of 34 degrees here, I'm going to go sine, and then I'm going to type in 34, that'll assume it's in degrees, and I'm going to hit enter, and it should tell me what sine of 34 degrees is. 0.559. But I'm going to round it to 0.559. So if this is 0.559 is equal to 15 over x, do you see how I'm really close to having it done now? Dot there. There it is. I'll just move the red stuff. Okay, I need to now get the x alone. So how do I do that? I guess I'd like to think of this as 1, and then I'm going to cross multiply. This times this, equal that times that, equals that. That's one way to do it anyway. So then I'm going to have 0.559 times 15 times 1. Now it's closer. Now I just have to divide by 0.559. Divide by 0.559. And I have x equals 15 over 0.559. Grab the calculator, do 15 on 15 divided by 0.559. I get 26.83. And what did I just figure out? If I look back here, this side here is 15. This side right there is 26.83. It must be in whatever units this one. I think that was in inches. This is in inches. All right. So that's how you do the solve for the variable shown in counting. And that's all I got for that lesson.